This is the section of electrons as waves, or matter as waves. We've got a beam of electrons travelling at this speed here, shines on a crystal, produces a diffraction pattern. And the reason is because electrons are waves. They can make a diffraction pattern like that. Here's the pattern. The mass of one electron is that, which is in your formula sheet as well. Some years they don't give it in the question, but it's in the formula sheet. Calculate the kinetic energy of one of these electrons in electron volts. So kinetic energy, it equals, you've got two formulas for that, p squared over 2m, or half mv squared. I'm going to use the last one, half mv squared, so that's half times 9.1 by 10 to the minus 31, that's from there, times the speed, 1.5 by 10 to the 5 squared, which gives me 1.02 by 10 to the minus 20 joules. And they want this in electron volts, so I divide it by 1.6 by 10 to the minus 19, which gives me 0.065 electron volts. Right, the beam of electrons are now removed and replaced by a beam of X-rays. The resulting pattern has the same spacing as that produced in the electron beam, so that means the wavelength of the X-ray equals the wavelength of the electron. Calculate the energy of one of these X-rays and photons. This is quite a hard question. There's a lot of calculating, so I'm going to put my plan up here. I start with my electron. What I'm going to do is I'm going to find out the wavelength of the electron, and then I know that's equal to the wavelength of the X-ray, and I'm going to use that to give me the energy of the X-ray. So that's my plan. Right, let's go. First one, wavelength of the X-ray. Well, a formula I can use, wavelength of the electron is it equals h over p, which equals 6.63 by 10 to the minus 34. I don't have p, but I know, I'll just write it up here for you, p equals mv, mass times velocity. So I'll put those in, 9.1 by 10 to the minus 31, it's a mass, and velocity was in this question here, 1.5 by 10 to the 5. And that gives me a wavelength of, what I did on my calculator, 4.86 by 10 to the minus 9 meters. That equals the wavelength of the X-ray. Wavelength of the X-ray equals 4.86 by 10 to the minus 9 meters. Cool. Alright, now I've got to find the energy of the X-ray. Well, the energy of an X-ray, we can use hc over lambda, 6.63 by 10 to the minus 34 by 3 by 10 to the 8, all over lambda is 4.86 by 10 to the minus 9, and that gives me 4.0.095 by 10 to the minus 17 joules. Energy in joules, as I use this Planck's constant, I need to put that in electron volts. So now I've got to turn it into electron volts by dividing by 1.6 by 10 to the minus 19, which gives me 256. So that was my pattern. I started off by getting the wavelength here, that was equal to the wavelength of the X-ray, there it is there, and I use that to work out the energy of the X-ray, and then to convert it to electron volts. This is a very tough question. Every year they sort of ask a very similar question, and it's very tough, so you actually do require to practice this quite a few times until you get it.